Hello, I hope you guys are doing fine. In this video, I will be going through the solution for mathematics analysis and approaches, standard level, May 2023 paper 2 time zone 2 exam. This video will focus on section A only. Keep in mind, this is paper 2, meaning this is a calculator paper. So you will need a graphic display calculator in this paper. If you don't, then you will require more time to solve each question in this paper. Or in the worst case scenario, you won't be able to solve the question. Before we start, please remember that the solution was made before IB published the official mark scheme. So it is recommended that you try to solve the questions as well. Here we go. Math AASL paper 2. In this video, I will also show you how to use graphic display calculator, specifically Ti-Nspire CX, in solving question in paper 2. Number 1, a botanist is conducting an experiment which studies the growth of plants. The height of the plants are measured on 7 different days. 1, 2, 3, 4, 5, 6, 7. The following table shows the number of days D that the experiment has been running and the average height H centimeters of the plants on each of those days, D and H. Question A. The regression line of H on D for this data can be written in this form. H is equal to AD plus B. Find A and B. So this is the same to Y is equal to MX plus C. H being the Y, D being X, because it is attached to A. So take out the calculator and choose list and spreadsheet. Look for that icon. And then you will be taken to this. Go to the very top and give label. In this case, I choose D for number of days because that is given there. And I choose H for the average height because again, it is given. And then input the values. So input all of these values for number of days and input all of these values for average height, like so. And then choose menu, statistic, start calculation, and choose, well, you can either choose number 3 or number 4. Just remember the format. If you choose number 3, the format is MX plus B. Here I choose number 4, A plus BX. The calculator will then ask you, which column is for X list? You can click this arrow and the drop-down menu will appear and you choose D because that's where we put the data for X values. And then you do the same thing for Y list. So choose H. And after that, the calculator will show you the result in this form, A plus BX. In the question, this is the form. Let's take a look at B. B is not attached to any variable. So B is just the same as A. Therefore, that B is equal to 7.22 in 3 significant figure. Now, that A is attached to another variable. Therefore, that A is just the same to this B. Therefore, A, that A there, is equal to 1.93 in three significant figure. I hope that's understandable. Next, you are asked to find the Pearson product moment correlation coefficient, or R. Again, from the same screen, you scroll down and find the value of R, which is 0.991. All right. Next question. Question C. Use your regression line to estimate the average height of the plants when the experiment has been running for 20 days. Okay, so this is our equation now. Remember, this is the format. H is equal to A times D. We know A. So H is equal to 1.93D plus B. B is 7.22. And the number of days is given 20. So substitute 20 here. And then you can find the average height, which is 45.8 centimeter. Number 2. The following diagram shows two buildings, that building and that building, situated on level ground. From point P, that point there, on the ground directly between the two buildings, the angle of elevation to the top of each building is theta. And diagram not to scale. The distance from point B to point A is 150 meters. The distance from point B to point B is 90 meters. The distance between A and B is 154 meters. Find the measure of angle ABB. We use cosine rules in this case because we want to find that angle P, and that angle P is located between these two sides, and the side opposite the angle P is also given. Therefore, cosine rule is the suitable one in this case. So we have this expression. All right. Simplify to get this. Now to find angle P, we use cosine inverse. So in your TI, you go to calculator and then click that trick button. And then you choose cosine inverse. And then you want to input this fraction. So you click that button, okay, and then click that fraction form, okay, like so. And then you input the values. Click enter, then you get the angle P, which is equal to 75.2 degrees. Next, find the height H of the taller building. Let's make a little sketch there. We need to find that angle theta, which is equal to 180 subtracted by that angle P divided by 2. That gives us theta, which is 52.4 degrees. And using SOHCAHTOA, sine 52.4 degrees is equal to the opposite side divided by hypotenuse. Therefore, H is equal to 119 centimeters. Number 3, the amount of a drug in milligrams, mg, in a patient's body can be modeled by the function A of t is equal to 500 multiplied by e to the power of negative kt, where k is a positive constant and T is the time in hours after the initial dose is given. Question A. Write down the amount of the drug in the patient's body when T is equal to 0. Now, this is very straightforward. You substitute T is equal to 0 into this function, like so. Therefore, the amount of drug is equal to 500 milligram. Next question. After 3 hours, the amount of the drug in the patient's body has decreased to 280 milligram. Find the value of K. So the time is 3 hours. Therefore, A of 3. So we substitute T with 3 is equal to 500 times E to the power of negative K times 3. And we know the amount of the drugs after 3 hours, which is 280 milligram. So A of 3 is equal to 280, and that's equal to 500 times E to the power of minus 3K. Now let's use TI. So from menu, choose algebra, and then choose numerical solve or nsolve. And let's input the equation here. So nsolve, open bracket, 280 is equal to 500 times E to the power of minus 3 times K. And this equation is in terms of K. And then you click enter and you get the answer. Therefore, K is equal to 0.193 in 3 significant figure. Now, next question. The second dose is given T hours after the initial dose. When the amount of the drug in the patient's body is 140 milligram. Find the value of T, okay? Using nsolve again in your TI. Let's write the equation first. A of T is given, which is 140. So that is 140 milligram is equal to 500 times E to the power of negative 0.193 uppercase T. So input this equation into TI like so. Here I use lowercase t. You can use uppercase T if you want. And the answer is 6.60 in 3 significant figure. If you do it manually, then you do this. And since we are using TI, we don't need to go through this. Just use nsolve. There you go. Next, question 4. The weights W grams of bags of rice packaged in a factory can be modeled by a normal distribution with mean 204 grams and standard deviation 5 grams. Question A. A bag of rice is selected at random. Find the probability that that bag weighs more than 210 grams. Okay, let's use TI. Choose menu and then probability. Well, this question tells us already normal distribution. So we go to distribution and then choose normal CDF. Okay, click that and you will get that display. And for the lower bound is obviously 210 because it says the bag weighs more than. So lower bound is 210. For the upper bound, input any large values. So input any large values. Mean is given 204 and standard deviation is given 5 gram. And then you click OK. And there you go. That's the answer in 3 significant figure, 0.115. Next question. According to this model, 80% of the bags of rice weighed between W grams, lowercase w, and 210 grams. Find the probability that a randomly selected bag of rice weight less than W grams. Let's make a sketch for this question B. Again, this is a normal distribution, so we sketch a bell curve like so. The question says, according to this model, 80% of the bags of rice weigh between W and 210. So that shaded area is equal to 80%. And we know that area from part A, yeah, 0.115, which is equal to 11.5%. Therefore, we can find this section here. 100% minus 80% minus 11.5. So there you go. That's the answer for B. Probability when the uppercase W is less than the lowercase w is equal to 0.085. Next question, find the value of W, that W there. But this time, we know the probability. The area under the curve is equal to the probability, but we don't know the value, in this case, W. So this time, we are going to use inverse normal. Click menu, and then probability, and then you choose distribution, and then you choose inverse normal, and then you will arrive to this window. The area, which is the probability, is equal to 0.085, the value that we found previously in part B. The mean is given 204, this one there, and the standard deviation is also given 5 grams. And then you click OK. Then you will get the value of W, which is equal to 197 grams. Next question. 10 bags of rice are selected at random. Find the probability that exactly one of the bags weight less than W, lowercase w, grams. This is no longer a normal distribution case. This is a binomial distribution question because there are two possible outcomes when the bag is less than W grams or when the bag is more than W grams. So let's take out the calculator. You go to menu, probability, distribution, and then you choose binomial PDF because the question says exactly one of the bags, So choose PDF. Then we input the number of trial. 10 bags of rice are selected at random, so there are 10 trials. The probability of success in this case, when the bag weight less than W grams, this one here, 0.085, and exactly one of the bags, so X value is 1. And then you click OK. Then you get the answer. So there you go. Question 5. The expansion of x plus h all to the power of 8, where h is greater than 0, can be written as this, where a, b, c, d, etc. is an element of real numbers. A, find an expression in terms of h for a, b, d. Let's expand this binomial expression first, like so. My apology, there should have been power of 8 over there. Again, I apologize. There should be power of 8. Okay, so again, we can start from x having the highest power, and the power decreases by 1 as x progresses to the right. So x to the power of 8, x to the power of 7, x to the power of 6, and so on. The power of h is the opposite. It starts from 0 and increases by 1 as it progresses to the right. H to the power of 0, h to the power of 1, h squared, h cubed, and so on. Now, coefficient. This coefficient can be found using Ti. Okay, so choose menu, probability, and then combination. Okay, so put 8 there because that is the highest power, 8, and then all of the powers, 0, 1, 2, 3 until 8. And then you press enter, and these are the coefficient. So we put 1 there, 8 there, and then 28, 56, and 70. So we don't need to use all of these, yeah? Because the question only wants us to focus up until D. So that one there. So this is A, and this is B, and this is D. Next question. Given that A, B, and D are the first 3 terms of a geometric sequence, find the value of H. So we have the first 3 terms of a geometric sequence. To find H, we can relate this to the common ratio, which is the term after divided by the term before. So we have 28H squared divided by the term before. There you go. Is equal to 70h to the power of 4 divided by the term before, which is 28h squared. And then we can solve for h, which is equal to 7 over 5 or 1.4. Question 6. A particle moves in a straight line such that its velocity v meters second to the minus 1 at time t seconds is given by this function. For 0 is less than or equal to t, t is less than or equal to 4 pi. The graph of v is shown here. Let t1 be the first time when the particle's acceleration is 0. A, find the value of t1. This is a velocity time graph. Therefore, the gradient gives us acceleration. When the particle's acceleration is 0 means the gradient is 0, which can be located at the maximum or minimum point. Now the question says the first time. Therefore, the acceleration is 0 at that point there. So we need to find t1 at that maximum point. Let's take out the ti. So choose menu and then choose graph. And then input this function. Keep in mind the calculator only recognize x. Therefore, that t must be changed to x. And be sure you are using radian, not degree. So let's input the function like so. Again, we change t to x. And then click enter. And we get the same graph. Now we want to find the value of t, or t1, when the gradient is 0 at that point there, at that maximum point there. So what we can do, we click menu, and then analyze graph and maximum. Well, we know that the maximum is located there. but the calculator needs to be told where the lower bound is and where the upper bound is. Now let's start off with the lower bound. So go slightly to the left-hand side of that maximum point and then click. Next, the calculator will then ask you for the upper bound. So you move to the right, not too far from the maximum point, okay, and then click. And there you go. That is the x value, or in this case, the value of t1, when the acceleration or the gradient is 0. If you can imagine, a horizontal line is drawn there, and the horizontal line has the gradient equal to 0. Next question. Let T2 be the second time when the particle is instantaneously at rest. This means that the velocity is 0 because the particle is at rest, is not moving. Now, this is tricky. The question says the second time when the velocity is 0. This is the first time when the velocity is 0, and this is the second time. So this is the time that we want. So let's take out the calculator, choose menu, analyze graph, and 0, because we want to find the, well, basically x-intercept. So click 0, and we know that this is the point that we want, but the calculator again need to be told where the lower bound is. So we go roughly to the left of that point, okay, and then click, and then the calculator will ask for the upper bound. So we go roughly to the right of the x-intercept, click, and we get the answer. Therefore, T2 is equal to 11 seconds, yeah, because that is the coordinate, that is v, velocity. So this is what we're after, 11 seconds. Next, find the distance traveled by the particle between T1 and T2. This is T1 and that is T2. If we look at the unit here, velocity, the unit is meter per second, that's given there. And the time has the unit of second. Meter per second times second give us meters, which is the unit for distance travel. That tells us that we need to find the bounded area using integration. So click menu, choose analyze graph, and then choose bounded area. And the calculator will ask us which one is the first graph. So click that curve, and then the calculator will ask for the second graph. Well, let's click x-axis because the area is bounded by the curve and the x-axis. Next, the calculator will ask us for the lower bound. We can click that point, that maximum point that we get previously, and then the calculator will ask us for the upper bound, and we have to click that point, the 0 point that we found in part B, and we get the bounded area. Therefore, the distance traveled is equal to 7.83. So there you go. I hope this video helps you, particularly in using the GDC, in this case, Ti-Nspire CX calculator in paper 2. Thank you very much.